know, for a long time that they are immunogenic. And the result of polyclonal response might be very effective to produce a better vaccine against the virus.
So with natural infection, we're getting M immune response, N immune response, S immune response, and about 20 others, in fact.
That's right.
So natural immunity is going to give a better quality of immunity than the specific S gene vaccine immunity. Is that sort of the...
чудо это женская, да, мужская это технология, ну просто завораживает, ну и чего как,
The thinking here.
We have always knew that, actually, John, I don't remember any respiratory virus that if it has a vaccine, its vaccine is more effective and its memory is more than the natural infection. But it's not an anti-vax message.
No.
Yeah, because we need vaccine. If the vaccine has reduced the number of mortality, it's a very good success. But when we are talking about the science, we have to talk about the reality, as you told before, and it's the reality. The immune system, different hundreds of epitopes on a protein can produce a polyclonal response that their bonus effect is more effective than only a directed response toward the special part of the protein or the special part of the virus, you know.
And do you suspect that natural infection will have a greater longevity?
Yeah, I believe so, yeah.
Do you think we might be talking years here, or, I know it's an unfair question, but do you think it might be a long time?
Yeah, for most respiratory viruses and intestinal viruses, the immunity is not for whole life. You might infect it different times in your life, but the next time, normally the severity of the disease is less, you know. For the first infection, normally immunocompetent person are the most severe one. But when you infected after 2, 3, or n years from now, they are normally softer, less severe, unless the people is immunocompromised. You know?
So the hope is that natural infection is going to generate a milder illness for years. We don't know how many years, but years into the future.
But yes, because when you see back and look at the evolution, we had a lot of these viruses that are existing now. Some of them did the same thing that SARS-CoV-2 when they were new and when they made an outbreak. But after that, because of this immunity, the whole immunity or herd immunity, they become softer, they become like influenza, like seasonal coronaviruses and other viruses around us. Yeah, we have reached to an equilibrium with them, or immunity. The SARS-CoV-2 virus was the most, recent one, but it wasn't the most pathogenic one. We had experienced a lot of these infections before. Our ancestors experienced that, but at that time we didn't record that. We didn't have PCR. We didn't have this.
So humans have been getting exposed to coronaviruses for thousands of years.
Sure.
Yeah. Now, okay, so that's interesting about the longevity of the response.
Может комплекс, может я действительно не самый, да, ну или даже это не важно. То есть как бы, да, то есть в чем моя проблема, что за это, да, комплексно, нет, но это не важно. Не я, значит, это говорит, да. Как прожить, ну он о себе так говорит, потому что, да, ну да, ну это ладно, и что еще, да, значит, да, понимает, да. Да, мама твоя была, да. Как улучшиться и улучшить себе, да, как сделать легкость, да. Рабское служение, то есть, да, не убить себя старыми крюками какими-то, да, понимаете. Да. То есть то, что, ну, пороки как бы, да. Найти себе какие-то рычаги, да, возмездие, кстати, да, то же самое говорил. Себе самой, да, вот это он и делает, да. Ну, это условно, да, ну, вот я понял просто, да. Нет, это ваше, это, ну, хорошо, давайте, можно совсем соглашаться, это тоже, но это не всегда работает. Это всегда ладно, постно, это пост-класс, пост. Нет, просто начхать. Просто вы себе, можно сказать, немножко, да, то есть, я вам все не верю, понимаешь? Я немножко, да, то есть, я во все не верю, и мне моя жизнь дорогая, а жизнь это не то, что вы мне пытаетесь объяснить. Я вам не верю просто, да. Вы такие все отдыхаете, семьи. У меня даже семьи нет, и если я даже была бы, и я бы начал отдыхать, может, как-то получше можно как-то и... Может, это не лучший вариант, как минимум, да, понимаю. Да. Ну, короче, не моя уже эта история.
In my mind is if we take a country like South Africa, or a country like Iran, where, say, 75% of the immunity that is enjoyed by the population is as a result of natural exposure. And if we take a country like the UK, where most of the immunity is as a result of vaccine, or if we take a country like Australia, where all of the immunity virtually is as a result of vaccine, what are the implications of that for Omicron?
So, actually, I always thought that countries like Australia, New Zealand, and the countries that you mentioned will experience the infection, because these vaccines, the current vaccines for SARS-CoV-2 doesn't prevent infection. They might reduce the number of death and severe disease, but they don't prevent the infection, because the the immunity coverage of them is less than the threshold for herd immunity of the Omicron. So people get infected, but fortunately, because they are vaccinated, the number of deaths is going to be reduced, and the herd immunity is produced based on the combination of natural immunity and vaccine immunity. So
I think you've answered a critical question there, Bezad, actually, because my concern was that a country like Australia, where it's all vaccine-induced immunity, that they wouldn't be enjoying protection against severe disease from Omicron. But it looks like they will enjoy protection against severe disease, even though they're only sensitized to the spike protein, not the polyclonal response.
We have to see that. And one of the most interesting things about comparing countries together is that they have different situation at the special time, because Australia and South Africa are located in the southern hemisphere. And you can't easily compare the country that is in northern to southern, because now it's winter here, there is the summer, and the level of UV and other parameters that define the severities. Have to see what's going to happen. But personally, I'm very hopeful that the number of severe disease and death is going to be reduced in countries like Australia, because they have this level of good vaccination. I hope so, but this is
well, thank goodness for the other few hundred protein, the other few hundred amino acids on the spike protein. The T cells are still sensitized to, which is going to prevent the severe illness and death. So basically, I think what you've said there is we're fairly hopeful that people in Australia or in the UK who've got protection against severe illness as a result of what we might call the old-style vaccines, they can get exposed to Omicron. They're not going to get very ill. And am I right in saying that their exposure to the Omicron is going to give their immune system a really big boost?
Sure, definitely, a really big boost, but it doesn't have still a guarantee that the person doesn't experience severe disease. But normally, for most cases, the likelihood of severity of the disease is reduced.
So this is really an ideal situation. Most of us are protected from severe disease, but we're still going to get natural immunity.
Yes.
On top of that, because we've been exposed to the natural Omicron variant. So this sounds like pretty good news, really.
Yeah, pretty good news. Yeah. But not a complete vaccine, I wish we had a better vaccine, like traditional vaccine, like measles vaccine, mumps vaccine, that when you use them, you don't get ill. But at the present, in this pandemic, with this short amount of time, we couldn't adapt ourselves very rapidly to make better vaccines.
Yeah. Now, most of the vaccines in Iran are actually not the mRNA and not the adenovirus vector. They're actually the attenuated or the dead virus. So in Iran, the vaccine given mostly has been the whole dead virus, the whole thing.
Actually, they are inactivated viruses.
Inactivated, that's the word I'm looking for. Yeah,
sure. Yeah. Yes, almost 85 to 90% of the population has received this inactivated virus, Chinese Sinopharm or a domestic one, Barakat, which has whole particle, but the response in comparison to attenuated virus is still lower, because we know that inactivated viral vaccine, especially with that type of adjuvant or alum adjuvant that they use in vaccine, induce more humoral response to cellular response. And with this type of humoral response, the response is not as complete as a whole virus that is amplified into the cell, attenuated virus. So most of the responses are humoral and antibody, and some of them are not neutralizing because during the process of inactivation, the structure of some proteins are changed, and the response is not as complete as the virus that replicates into our cells. We don't have any mRNA vaccine in our country, and almost 10% of the population or so has received DNA viral vector-based vaccines,
So we're left with a situation in Iran where most of the immunity, as you say, is as a result of the natural infection.
Yes, sure.
Induced by the previous waves. So basically what we're saying is the inactivated vaccine, they're good for generating antibodies in the short term, but they're not so good for sensitizing the B and the T memory cells for the longer term immunity.
Sure. And the type of antibody that is produced with inactivated virus are immunoglobulin G and immunoglobulin M, no immunoglobulin A. So the response and immune response is not as complete as the attenuated viral vaccines.
But that will be the same with the mRNA vaccines. They won't produce IgAs, will they?
Yeah, because they are introduced into the muscles,
Okay.
The root of infection is not respiratory,
So if you give an mRNA vaccine, you'll end up with immunoglobulin type A's in your mucous membranes.
With mRNA vaccine, no. The level of immunoglobulin A is not very high at the respiratory areas.
Right. Yeah. That's what I thought. Yeah. So how do you see the situation in Iran now? Because I think, can we assume that Omicron is going to go all over Iran in the next few weeks?
We have to wait and see. I can't exactly predict, but I think because the level of natural immunity is higher in Iran, the speed of propagation for Omicron is going to be lower than in comparison to many other countries that have immunity by vaccination. Almost 10 days ago, the Omicron cases was diagnosed in the country, but the number are still very low, and about 30 cases have been diagnosed. So I believe because of this buffering situation for viral propagation, the spread of the virus can be very limited in comparison to the time that the Delta was hit the country,
Yeah. Interesting. But in the South Africa situation, where there was a lot of natural immunity, Omicron was reinfecting. There was breakthrough infections from people that had a level of natural immunity, and they were getting mild disease, just not getting very sick.
It's quite possible here in Iran.
So it's possible that the virus could run.
Yeah. We have to see what's going to happen, but it is completely possible. because but another thing that I guess is that the level of natural immunity in Iran is even higher than South Africa. You know?
Yes.
Almost
Yes.
10%. You know.
Yeah. Interesting. So, do you think Omicron in places like the UK is going to replace Delta? Is it?
Sure.
It's out competing it? So in the same way that Delta basically eliminated Alpha,
Yeah.
is Omicron going to eliminate Delta?
Yeah, it's quite dependent on the R0 value of the Omicron. We don't know exactly the R0 value of the Omicron to compare with the R0 of Delta, but it seems that it's more infectious, and that and because it's more infectious, it finally displaced the Delta and become the dominant variant in UK and everywhere that it enters. You know.
So this sounds really good news. If Omicron's causing mild disease and Delta causes severe disease, the Omicron is basically sweeping out.
Yeah, sure.
The Delta
kind
is
of
getting rid of the Delta for
kind of
us.
like an attenuated vaccine, you know. It is not an attenuated vaccine, but can act like an attenuated vaccine. And John, one of my questions about the vaccine platforms is that why? Because I've studied virology, I know how they make vaccine, but I was not involved in the process of making vaccine. I'm more involved in diagnosis of the viruses. But my question is that why they are not still trying attenuated vaccines? They say it is dangerous, it's a pathogen virus, we can't easily be sure that it's safe. But we had attenuated vaccine for viruses that are more pathogenic than SARS-CoV-2. For example, yellow fever, measles. Measles is more pathogenic than SARS-CoV-2. When you see that the number of deaths because of measles is low, because the measles is an endemic virus, and we have herd immunity and vaccine immunity against it. But when, as a new virus, when it caused outbreak in Fiji Island, 40% of mortality produced by measles vaccine, measles virus. So we had attenuated vaccines against more pathogenic viruses.
Yeah.
So why don't we try attenuated platform for SARS-CoV-2? Because it's the nearest platform to actual viral infection, and it can result in a longer immunity and longer immune response.
I think people don't realise just what a dangerous disease measles is, and it still kills a lot of children around the world. It's a really serious illness if it's not prevented.
Yeah.
So basically, with the Sinopharm vaccine and the measles vaccine and the Iranian domestic vaccine, what people do is they brew up huge amounts of virus. And I presume you do that on a tissue that must have a cellular culture that we brew up the virus in. You end up with untold billions of viral particles, and then you attenuate them to stop them. Basically, you kill them off. You greatly weaken them. And then you inject these to develop this polyclonal immunity, which happens with measles. Now, the fact that the first generation of Sinopharm didn't work particularly well doesn't mean to say that this technology couldn't be developed to get a polyclonal attenuated vaccine. And the reason that is not done is really a good question. People seem to have put all their money in the mRNA technology, and to some extent in the adenovirus vector technology, while I think we could basically say in Western countries ignoring the tried, tested and proved vaccine technology of attenuating the whole virus. And the reason that is not done, I don't know the answer to that. Some people might suspect that it's commercial interests.
Yes.
Some people might suspect that. I wouldn't know, but some people might think that existing vaccine technologies are making a lot of money, so why experiment with another vaccine technology that you'd be going back to scratch on? But it would give a much more polyclonal response. So all we would need to do is get an attenuated vaccine, which is good at stimulating the T cells and the B cells, in addition to the antibody immunity. And then we'll be on to the thing.
Epitopes.
Да, и тогда смотри, ты такой сам себе, балет сам себе натанцевал, и пришел в балетное училище и сказал, ой, там скажут так, наоборот, понимаете? Да, понятно, это имело в виду наоборот. Вот я про это тебе и говорю, понимаете, да. Ну вот это она имеет в виду, да. Ну, да. Ну, а что ты можешь сделать, пока тебя не взяли туда? Вот это она о себе так думает. Работать это не женская тема, понимаете? У тебя единственная жизнь, не надо ее тратить, пытаться ее потратить на что-то мужское, потому что она у тебя не женская, да. Тебе что от меня надо вообще, да? Наверное, пока я пока, как видишь, не, я не хочу никого рвать, ничего так, это неинтересно, потому что есть что-то лучшее, есть что-то настоящее. Вот у нас ацтеки, как бы, да, сумасшедшая популяция нормальных людей. А как бы, да, понимаете, просто, ну, не важно, не суть разговора, просто, да, потому что, да. Гарантия того, что вот они сейчас все мои родственники умрут, что я себя не убью. То есть, как, что я также не умру, как они. Такую же жизнь интересную проживу. Интересную. Не такую, которую я запланировал. Да пошел к черту. Вот она себе. Да, вот это и было на самом деле. А я в это все верю, я уже учился в музыкальном училище, то есть как бы, да, то есть, ну, она про себя так говорит, да. Нет, ну да, нет, это моя стезя, короче, да, и все. Вот она тебе говорит, это не ваше дело, вас не касается. Тем более после стройки. Да, и еще это, да.
And the epitope is just part of the antigen that the immune system recognises as being foreign and generates a reaction to. That's a remarkably good question, and I don't think I have a scientific answer to that at the moment. So I'm optimistic that Omicron is basically going to be the end of this pandemic as it displaces Delta and it becomes an endemic common cold virus. Is this just wishful thinking on my part?
Yes, I think so. I have this belief, and I think after this huge wave in many countries, like Western countries, in UK, in US, Canada, most of the population obtained this permissive herd immunity with combination of vaccine and Omicron variant, and the pandemic will come to its end, you know, and the sporadic form of the disease or endemic form of the disease is going to be continued in next years. You know?
Yeah, for the next 5-10 years or whatever. Yeah.
Yeah, sure.
Yeah. So basically, Omicron is the best thing we could have hoped for. It's going to introduce massive herd immunity.
Yeah, because its pathogenicity is lower.
Yeah.
Its infectivity is higher, and most of the countries are vaccinated. Most of the involved countries are vaccinated, and it could be a very good news to finally reach to the end of this pandemic. You know.
So this pandemic's going to end because nature has just evolved this new type. It's not human beings being clever. It's just the natural evolution that's built into the ecosystem of the planet almost. It's
That's really the case. That was a very good sentence because we saw that still the natural immunity and natural event that has obtained us from getting ill and from getting extinct is working again, you know?
Yeah.
It's hopeful.
So given that the Omicron is so infectious from all the data that we have, and given that it's causing mild disease, if another variant was to evolve, that would only become the most prevalent variant if it was more transmissible than Omicron.
I still think it depends to the immunity. I believe that natural immunity in most people resulted in immunity for about 2 to 3 years. So I'm not quite sure that an infection, if another infectious variant evolves, it can easily be spread in human population as others. For example, when Alpha was first recognized in Iran, in only 4 weeks, it completely displaced the classical variant. After that, Delta, in only 3 weeks, displaced the Alpha. But Omicron couldn't do this to Delta yet, you know, because it is propagate with a lower speed than Delta. That's not because the Omicron is not more infectious. That's because the human bodies resist to get Omicron, you know, and the virus can easily propagate among population. You know?
Yeah. So even though the virus is more intrinsically transmissible,
yes,
it's actually being impeded by the immunity that's enjoyed by the population, and that's slowing the spread down. So when I'm thinking that if this pandemic will only become a problem again if there was a variant which outcompeted Omicron and was more pathogenic. And is it possible that could happen, that we could get a new variant which is very transmissible and yet still causes severe disease? Or does the fact that it's more transmissible mean the disease is likely to be less severe?
I can't completely say that it's not possible. It is possible because a variant might evolve that escape immunity as well as more infectious, so the tragedy starts again. We had this problem with influenza. Influenza virus always change, and always new pandemic can exist. So it is completely possible. But the nature of coronaviruses is different from influenza viruses because variation in influenza is much higher than coronaviruses. Coronavirus families are among the most conserved sequence families in RNA viruses because the enzyme that is responsible for their replication has this proofreading activity that can edit mistakes. Influenza doesn't have. Another reason is that the influenza genome is segmented. And when two influenza virus from two different species goes into a cell, this piece of genome can displace genome and a new progeny can be produced that might be different from their, from the ancestors, from the parents, and it can propagate to the population with new
It's almost
features.
like a sexual reproduction, isn't it? You get genetics from one virus mixes up with another.
Yeah,
Does that happen though? I mean, does that happen with coronaviruses? Because this Omicron variant does seem to be, it's not like the Delta, it's like something completely new, isn't it? Do you think there's been, can you get mixing of the RNA of coronaviruses if a host is infected with two?
Ну тело и тело, а жить-то на что? А след твой в мире какой? Да лучше бы не жил, я понял. Ну да. Уж не знаю, уже да. Ну,
Different types of coronavirus at the same time.
Actually, yes, different theories exist about it. Some strange, some bizarre theories, and actually it might happen in nature. It might happen by a person, in a laboratory. I don't know actually what happened, but the number of mutations are very interesting. It has a lot of bad mutation inside, and it seems that they are sorted accordingly, to a logic together, So actually, I can't answer this question exactly, but it's very strange. We didn't expect that during this short of time, this much of variant produced during the pandemic, Personally, I didn't expect that.
Yes, I mean, in January 2020, what we were saying is, well, the influenza virus doesn't self-correct, therefore you get huge amounts of mutation and it changes overnight. Whereas coronaviruses, because they do have this self-correcting enzyme, they tend to be genetically much more stable. But here we are, we've got all of these variants. I mean, I guess one point is the virus has just been so prevalent. There's been so much reproduction. There's just been a greater number of opportunities for the virus to mutate. But one question I get asked lots and lots, is it possible that a coronavirus can merge its RNA with a HIV, human immunodeficiency virus?
Yes, people talk about that. Actually, I don't actually know. In science, you can't easily deny something or accept something. It has to be proven.
Yeah.
But it's possible. It's possible because the RNA, if they co-infect someone, some genetic material change might happen. But as a scientist, I don't know about the rate, and I don't know about the likelihood that happens.
So we can't say it's theoretically impossible, but we don't actually know of an instance where it happened so far.
Yeah. Because during the evolution of coronaviruses, some coronaviruses has this protein, hemagglutinin esterase fusion protein. Some believe that this protein, and this similar to this protein, exists in influenza C virus. Some scientists believe that the recombination between coronaviruses and type C influenza viruses has resulted to obtaining of this protein from one of these species. So during natural evolution, this event might happen, and I can easily deny the possibility.
Is it possible that there could be another pandemic with a coronavirus or an influenza virus or a mixture of those two, or a virus we've never heard of next year that could have a really high mortality rate. Is that possible?
Yes, it's possible. Yeah, possible. It is possible. We have to prepare for the pandemic, because almost 5,000 species of coronaviruses are existing in bats, and we have recognized 500 of them. And always it's possible that they can change and they can obtain this possibility to transmit to human. So we have to be ready for other pandemics due to coronaviruses and other respiratory viruses. So it's not a good news for society, but we have to prepare to a better response, faster response, and prevent disease to propagate. The experience of COVID-19 showed that we had a lot of problems in countering a pandemic like that. You know?
So it's possible that there could be a really severe pandemic any time. Would it be? Would it? Could we say that this is almost certainly going to be zoonotic if there is another pandemic?
I think because of the nature of the coronaviruses, because they exist in other species, it is highly possible that if it exists, it would be a zoonotic. Especially bats are a real bad host for coronaviruses. Bats, they have a lot of coronaviruses in them, and when people get close to bats and hunt them and bring them into the human population or society, it might be very dangerous.
So basically what we're saying from virology is that there could be another pandemic that could be as potentially as infectious as Omicron. So it could go around the world, but potentially as deadly as Ebola. That's not a theoretical impossibility, is it? It is.
Yes, that's not true. But we were very fortunate that the pathogenicity of SARS-CoV-2 virus was not very high in comparison to many other viruses. And if it was, the number of mortality was much more higher, and the human nature was threatened, you know.
So have we been a bit lucky this time, really?
Well, yes, we were. Have to be thankful, yeah.
Yeah. So I mean, in virology, it's not impossible that you have a very pathogenic virus, very transmissible virus. That I mean, I don't want to be dramatic here, but it is scientifically possible that the majority of the world's population could be killed by a viral pandemic.
Sure. Yes, it is. Unfortunately, it's completely possible. And one of the threats to human being is the viral infection. So we have to be more prepared. We have to be more ready to reaction against them. And we need a very common sense for defending against viruses. In this pandemic, we showed that we are not ready to encounter pandemics. Some countries got their second, third, fourth shot. In some part of the world, vaccination rate is very low. And with this type of action, we can't assume that we are prepared and ready for another pandemic, you know. Yeah. We have to be more coordinated together. We have to work as orchestra when we are countering to
I'm not too optimistic that that's going to happen anytime soon, unfortunately. So, I mean, every year there's outbreaks of bubonic plague caused by Yersinia pestis, the bacteria.
Yeah.
But it's not a big problem because we treat it with antibiotics.
Yeah.
So is the future to stopping a pandemic having a very good quality antiviral drug where we could just clobber, just eradicate So just like we can eradicate, so in India there might be half a dozen cases of bubonic or pneumonic plague. No problem, treat it with antibiotics, that kills the bacteria, stops the person from being infectious. Is there any hope at all that we could have such a competent, comprehensive antiviral drug?
Yeah, we have to be hopeful, or we always have to be hopeful. We always have to work to make new antivirals and better antivirals. But there's a fact. Making antiviral is much more difficult than making antibiotics, because viruses are very simple. They replicate into our cells. So you have to find a compound that has this selective toxicity to inactivate the virus and doesn't harm the cell. So it's very difficult. Another problem with respiratory viruses is that in most of the case, the harm to the lung and to our body is not produced by the virus itself. In ARDS, or acute respiratory disease syndrome, most of the time it's the immune system, it's the immunopathology that results in ARDS. So viruses came to our body, it runs some processes, it hits some processes, and then run. And after that, the processes that started act like a cascade and resulted in a bad situation. So when you eliminate the virus with antiviral, the outcome might not change very much after the cascade is run. So it's very difficult. In antiviral, I believe that if the antiviral to a respiratory viruses starts in a short time after the infection, it might be useful. But if it is late and the harm is produced and the people has this ARDS, it might not be very effective, you know.
I've got another question that's really quite unfair, but you're doing so well so far. So the immune system is this amazing structure. It can recognize 8 or 9 billion different foreign epitopes or antigens. It's just incredible. So why does it make the simple mistake of overreacting and killing the person who owns the immune system when it's exposed to a simple virus? Why is the immune system not better designed than this, that we don't get this overreaction?
Yeah, actually, the response to some pivotal questions might be very different. So I'm not an immunologist. I know immunology as immunovirology, we humans don't know all aspects of the immunology. You know, we don't know a lot of things. But I believe that responses sometimes they are out of control. In hepatitis B is like that. The hepatitis B virus doesn't harm to the liver, it's the immune system that attack and resulted in fulminant hepatitis. The same situation is exist in ARDS with many viruses like influenza and SARS-CoV-2. I always example this like, imagine that the city or the country is occupied by some foreign forces. Immune system has 3 choices: come to a city and reasonably defend the city and make them go out. It can do no reaction, so viruses can remain and propagate, and the city is occupied. Sometimes the reaction is so big, they attack the city with a lot of bombs, a lot of reactions, and even the enemy is killed completely, the city is destroyed completely. The same situation is occurred, yes, in fulminant hepatitis and in ARDS. Sometimes when a process starts and the cascade resulted in a disaster. That's why doctors give immunosuppressor drugs to the patient who experience ARDS at the early phase and try to oxygenate the liver and make the results better. You know, that's not all because of viruses, and that's why maybe because in children the response are more controlled because they don't have this actually complete immune system. They don't overreact, and the disease is milder in them. You know.
Right, so children are actually protected to some extent by their immuno-incompetence.
Kind of. The doesn't have this rigid immunity that acts, you know, in an uncontrolled way.
And then this is what we saw in the 1918-19 pandemic, where young adults were dying, more so than people, you know, my kind of age, and then older people were dying as well.
Let's hope, hopefully that.
So.
This all my respect. Тут тоже надо двигаться. Жить-то как надо, жить-то как... Да. Понимаешь, ну что, делать хочется, да. Понимаешь, хочется, что...
so we've seen this before.
Yeah, situation in influenza might be different. Sometimes the virus can produce damage to the lung. Measles can produce damage to the lung. Influenza can produce damage to the lung. Some kind of hepatitis viruses can produce damage to the liver. But it completely depends to the virus and the type of immunity that activated against the virus and in different pathophysiological situations. You know?
Now, Omicron seems to be sweeping through Africa at the moment.
Yeah.
But the reports that I'm getting from colleagues in Africa is that there's not a lot of people getting sick. We hope it stays that way. But the vaccination rates in some areas are 2, 3, 4, 5%. You know, it's essentially nothing. So, do you think that there could be cross-immunity from other endemic viruses or other pathogens or even parasites in Africa that is protecting people against Omicron and indeed the other SARS coronaviruses as a form of cross-immunity?
It's one of the possibilities. Genetic markers are another possibilities. But personally, I believe that climate and weather should be more studied in different pathophysiological and situation. I believe that the climate has a huge effect on the severity of disease. Some disease are severe in hot climate, some of them are severe in a colder climate. But I think we have to consider all these parameters to find out what's actually the main reason for that. Why the severity of disease in Africa, in Afghanistan, in Iraq is less than many other parts of the world with a lot of amenities in medicine. So the climate might be a very important contributing factor, and as you said, response to other pathogens might participate in these reactions. Yeah.
Fascinating. Now, I do have you got time for a couple more silly questions?
Yeah. No.
How many viruses are there? How many types of viruses are there in the world?
There are a lot of viruses in the world. In human, about 300 different viruses are recognized. In other species, different viruses are recognized as well. In bacteria, in fungi, in algae, in insects, plants, every single organism that you study has a lot of viruses. So it seems that viruses are the most abundant creatures on Earth. But we know very few of them. About 4,000 viruses, 4,000 viruses are recognized by human, but we believe that they are very huge, both in terms of diversity and the amount, the number.
So we know about 4,000 types of virus. There could be millions of different types of virus. Yeah. So like humans have one set of viruses that can infect them. Dogs have another set of viruses that can affect them. Lizards have another set. Plants have another set. Bacteria have another set. Fungi have another set. So there's like, and normally, unless we have spillover or zoonotic infection, the viruses generally stick to their own particular species. So every cell type has got its own subset of thousands of different viruses that can infect it. This is just mind-blowing. The complexity of this ecosystem.
Yeah, definitely. And some of them are useful. We use some of them for good reasons. Some of them are used as antibacterial. Osteotherapy is a science, when some resistance exists towards some antibiotics, microbiologists use bacteriophage to defend against some pathogenic bacteria. They might be useful even
So we need to learn to use viruses as a species to our advantage.
That's true.
Yeah. So if you go outside into a natural environment and you take a handful of soil, that's going to contain lots and lots of viral particles.
More than 10 to the power 11 viruses might exist in 1 gram of soil.
10 to the 11. So that's a 1 with 11 noughts on the end.
Yeah.
And this is everywhere, all around the world.
Yeah, all over the world. Yeah, everywhere.
Yeah. Yeah. And all these specific types, all the specific cell types. So mushrooms have their own type of viruses.
Yeah, definitely. We know very few viruses. The viruses that infect human and some animals and some insects, but we don't know absolutely most of them, and they are around us. They can do a lot of things that we are not aware of them. You know?
So the assumption is that all of these millions of types of viruses and untold numbers of individual viral particles are necessary for the functioning of the ecosystem that we enjoy.
Yeah, sure. They can control the population of some insects, some plants, and they have some effect on the ecosystem like other organisms in the ecosystem. So they might be useful for us. And human pathogens are the viruses that we mostly focused on them, but there are a lot of them that might be useful. You know?
So the ecosystem on the Earth is a lot more complicated than we thought. Not only is the plants, animals, fungi and bacteria, there's untold numbers of viruses that do things that some of the things we know about, and I guess many of the things we don't know about.
Yeah, sure.
Now, are the viruses in the sea as well? There's marine viruses.
Yes. The same amount of viruses, 10 to the power 11, exist in 1 milliliter of in some oceans, you know. They're all around us, and fortunately only a few of them can infect human.
Yeah.
You know? Almost 300 viruses can infect human.
So the assumption is that without all this massive diversity of viruses, the ecosystem would not be a functional ecosystem to support human life.
Yeah, sure, definitely.
So we complain about pandemics, but we actually need viruses.
Sure. Yeah, to control the population of other organisms to make the ecosystem act normally, you know.
If you know. So again, I know there's different theories on this, but where did all these billions of types of viruses come from?
Actually, we don't know the origin of viruses. As some believe that they are the first form of living on Earth, the first form of living produced from an RNA, and this RNA is a virus. Some believe that they are the deteriorate form of intracellular parasite like Rickettsia, Mycoplasma, and other bacteria. And some believe that they are autonomous nucleic acids that come from our cells, living cells, and can propagate autonomously. And some bizarre theories that says viruses came from other planets with some kind of
the panspermia idea. I don't buy the one about coming from bacteria, because there'd have to be billions of different types of bacteria, simplifying into viruses, and
some viruses
we basically don't know where they came from, but we do know that we do need them.
Yeah, but some viruses might evolve differently, you know. There is a difference between viruses with DNA as genome and viruses with RNA as genome, and the viruses that use both of them. We actually don't know the real origin, but the origin might be different. So we call them virus, they might be different organisms with different histories, you know.
Could be completely, But the genetic coding is the same between the RNA and the DNA viruses. The codons, the genetic sequences code for pretty similar, generally amino acids, so that they are related in some way, aren't they?
All forms of living have this genetic codons, you know. It is the meaning of codons is almost similar from viruses to worms to insects to human, you know. So
all life on Earth, whether it's a simple RNA virus or us, is working on the same chemical genetic code principles.
Yeah. But they have some special things for their own, you know.